Welcome to Web Handling. My name is Dave Roysam. I am super excited to continue our Material Matters mini-series with a discussion of porosity, permeability, and roughness. This last clip in our Material Properties series is one of the most difficult for three reasons. First, it is not important to some of you, such as film converter running at very slow speeds as just one example. Second, it is extremely important to others, such as nonwovens, as just one example. Third, each one of the topics of porosity, permeability, and surface roughness deserves a chapter all to itself for those who have rough products. So all we can do here is introduce the properties and highlight just some of the concerns. So why would you want to know about roughness-related topics? There may be several motivations depending on your web processes, and customers. For web handlers, we want to know about roughness because it informs us about air entrainment, traction, roller design, and windability. More about these essential topics in the next slides. For certain web products, roughness-related topologies are central to product performance. These would include, but are not limited to, absorbent capacity and absorbent rate, insulating value, filtration properties, permeability, printability, and many, many more. Each of these properties are distinctly defined and distinctly measured. However, there are some relationships. For example, most materials that are porous are also permeable and also rough, though closed cell foam is one exception. However, rough webs are not necessarily porous or permeable. So what are these different properties? Porosity is the void fraction of airspace in the web. It can range from 0.999 for the space-age aerogel insulation to 0.9 or so for sintered metals to much, much less for film or rubber, for example. Porosity would be super important for products that are intended to hold or store liquids, or are intended to be insulators. Permeability is the lack of resistance to fluid flow. Permeability would be important for products such as filter materials, as well as many others. Surface roughness is, well, roughness. However, scientists call this tribology. Tribology is super important for web handling and friction. That would include, of course, most of web handling and winding. Returning to web handling, a topic near dear to my heart as well as most of you on this all web handling channel. Surface roughness tells us when air entrainment is important. If it is, we may need to consider grooving of rollers. If it is, we might need a nip to exclude air to avoid winding rolls that are too loose. So, how would you know whether air is important? Easy, at least in concept. Air is important only when all of the following are simultaneously true. The web is not narrow, the speed is not slow, and both the web and the roller are not rough. Narrow is perhaps the easiest to describe. If the web is narrower than, say, 10 centimeters or 4 inches, the air can easily find its way out to the edges, and thus air entrainment is almost never a factor. On the other hand, by the time the web is 10 times that wide, The effects of air escape from the edges are usually negligible, except for the special case of air buckles found at the bottom of film rolls. Obviously, there are several factors here, and each is on a continuum. So let me just give you 3 examples of the interplay of roughness of webs and speeds. Film is usually quite smooth and can lose traction noticeably at, say, 30 meters per minute. Ordinary newsprint might be run and wound to at most 100 meters per minute without special roller grooving or winding dips. Craft paper, such as for grocery sacks, is rougher still. As such, the surface of the paper itself can handle more air, perhaps allowing you to run and wind up to, say, 300 meters per minute. So, what if you wanted to run smoother materials such as film? Well, you might see a loss of traction at a mere 30 meters per minute, so path control would be trouble, and your wound roll might be so loose to handle, ship, or unwind by your customer. So, what would happen if you needed to run faster than, say, 30 or 100 or 300 meters per minute? Well, you better get the must-have 750-page Web Handling Handbook, because that is the best source for how to size and specify roller grooving. That is the best source to tell you how to apply nips for winding. Nonwovens are a widely variable set of chemistries and constructions that are used for an even wider set of products. Most nonwovens are formed of strands of thermoplastic fibers laid down on a belt. Some products, however, are made of strands of glass fiber, such as what you might find in the walls of your house. Woven textiles may share some of the same concerns as nonwovens listed here. For most consumer industrial products, absorbent capacity is desirable. For nearly the same set of products, absorbent rate is also desirable. Unfortunately, if you increase capacity, you tend to decrease rate. While there are some mitigating factors, much of this is determined by Fick's law of diffusion, capillarity, and fluid flow models. Then there are products that are used for filters and insulation, where other properties are most important. Obviously, any discussion beyond this would be very product dependent, so we will leave it here for right now. Returning to surface roughness, which is of great concern to web handlers, we have many pages of detailed discussion in the Web Handling Handbook. For those of you who have nonwovens or other products, you are pretty much on your own to do some combination of a Google search or inquiry about the web properties and web tests that are used in your industries. There are 3 starting points for a discussion about the details of the web handling aspects of surface roughness in particular. The first is a book by a longtime researcher of roughness effects on traction and winding. Note that this book by Hashimoto is a PhD level discussion of tribology and thus may not be for everyone. The second is the must-have 750-page Web Handling Handbook, written by myself, Tim Walker, and Dilwyn Jones. Last but not least is my award-winning and trademarked Web 101 class that has been taken by 5,000 people just like you. Here you will learn how to use material properties and testing to size and maintain and operate and troubleshoot web machinery. Thank you so very much for joining me in this Material Matters series. This concludes this series, at least for now, because we have many other topics that need our web handling attention. Stay tuned for the next clip where we will introduce a new mini-series on moisture and temperature effects on webs and rolls. If you have a topic you would like to hear about, let me know in the comment section below. If you found anything interesting or useful here, please like and share and subscribe. Also, please consider supporting the work of this channel using the Patreon link below. See you next time.